Hi everyone. Today again we are going to evaluate another limit expression of calculus. What is that? That is limit x tends to 0, log to the base e cos of sin x whole divided by x square will be how much? This sum can be done in two ways. One is the normal conventional way of limits by using the fundamental rules. Else we can apply L'Hospital's rule that I have shown you in the last video. Today I shall show you how to derive the value of this limit using L'Hospital's rule. First of all, we have to check if we can apply L'Hospital's rule here. So what is the numerator? Numerator is the new log of base e cos of sin x if x tends to 0. That means we have to put the physical value of x equal to 0 here. If x equal to 0, then sin 0 is 0 and then cos of sin 0, that is cos of 0 is 1. Now it should be then log of base e of 1. Log 1 is 0, we know. So the numerator is 0. Now what is denominator? Denominator is x square. If we place the physical value of x equal to 0, then it will be also 0. So my limit is the form of 0 by 0. So I can apply L'Hospital's rule in this limit. How? What does L'Hospital's rule say? It says that if it is in the 0 by 0 form, then it should be equal to limit x tends to 0 ddx of, because derivative of the numerator, that is log of cos of sin x, and log's base will be e divided by ddx of x square. We know that ddx of x square is nx to the power n minus 1, that is 2x. It is very simple. And by chain rule, if we have to calculate ddx of this, then we know that ddx of log x is 1 by x, that I have also shown you in the last video. So it should be ddx of the numerator will be, obviously it is 1 by cos of sin x. At the same time, I have to derive on the top ddx of cos of sin x. So what will be the ddx of cos of sin x? Ddx of cos x means minus sin x. Then it should be minus sin of sin x. And in the inside there is a sin x, so it should be cos x whole divided by cos of sin x. That is the derivative of the numerator. So in short, what I can write is sin of sin x divided by cos of sin x is tan of sin x. So it can be further written as, here the value will be tan of sin x, there will be a minus sign, into cos x. So this is the value of the derivative of numerator. So let us start now. So my entire expression of the limit, exact what we have got from the definition, after derivation, after differentiating it, it is getting evaluated as limit x tends to 0 minus, I am taking it outside because it is a constant, then tan of sin x into cos x divided by 2x. Derivative of x square was 2x. Now let us see what we can do here. So I can writing is minus limit x tends to 0 sin of sin x divided by cos of sin x into 2x. On the top there is another cos x. What I am doing now? Now sin of sin x, if I consider sin x as a new variable, so I can assume that sin x equal to y. Now if x tends to 0, sin x is also 0, that means y also tends to 0. So this can be written as minus limit y tends to 0. I am separating into two parts, sin of sin x divided by cos of sin x, I am keeping aside, 2x divided by sin x into sin x. Here it is cos of sin x. On the top there is a cos x. I am explaining you what I have done. Sin of sin x is already there in the numerator. 2x, I am just writing is 2x by sin x into sin x. Sin x and sin x are nullified. So the entire expression remains 2x. In the below, already cos of sin x is already there. Why I am writing so? Let us explain that way. Now already I have assumed that sin x equal to y. That means I am using the formula of limit x tends to 0 sin x by x equal to 1, this basic rule here. So here it can be written as sin x, I have assumed it as y. So minus limit y tends to 0, it is sin y into cos x divided by 2x by sin x, that is 2x by y into y into cos of sin x. Right? This is the derived formula as of now. 2x by sin x is y. So 2x by y into y, and then cos of sin x, I am not touching it. Or rather, I can write cos of sin x as cos of y, because sin x already is substituted as y. Okay. At the same time, limit x tends to 0. So this can also be written as, okay, let it keep this expression as it is. Now already y is a substitution of the variable x. So I can write here limit y tends to 0. I am taking sin y by y in another expression. Y goes up in the numerator because it is in the denominator section of denominator. So limit y tends to 0, y by 2x into cos x by cos y. Right? So what is that now? Limit y tends to 0 sin y by y is 1. Next is limit y tends to 0 y by 2x, right? Y is sin x as per my substitution. So sin x by 2x into cos x by cos y. Here I will be again separating it as limit y tends to 0. That means already as per our expression I can write limit x tends to 0 because y is sin x. So I am separating it out, sin x by x. I am taking half outside the limit, and the next pending part is limit y tends to 0 cos x by cos y, right? Or I can write it limit x tends to 0 1 by cos y into limit x tends to 0 cos x. I am explaining this step once again. Why I have written this? Because limit y tends to 0 sin y by y is 1, so that is why I have written it 1. Limit y tends to 0 sin 2x by 2x into cos x by cos y. Now sin x by x is 1, so half I have taken out of it. Y tends to 0 means x also tends to 0, so that is why this part is also evaluated as 1. Rest of the part is mixed with x and y. Now here limit y tends to 0 1 by cos y and limit x tends to 0 cos x. So this part is half, this part is 1, this part is cos 0. If I put y equal to 0, then it is also cos 0 equal to 1, and if x tends to 0, cos x is also 1. That is, the entire value will be half. So this is a complex limit, quite complex limit, but this can be resolved in this way by properly substitution of the two function variables and applying L'Hospital's rule. If you like this video, I will request everyone to view, watch and subscribe my channel as well. Thank you.